Happy Friday. I'm glad we made it to the end of the week. Yesterday, I introduced solving real life equations, and in math terms, that usually looks like word problems. So, we have more word problems today, and we're going to practice writing that equation and solving those equations for more practice. Next week, we'll be moving into inequalities. And it's pretty much the same thing. It just doesn't have an equal sign. It has an inequality sign. So we'll probably have a test sometime next week. But today we're working on real life equations again. So the first thing I always do when I'm trying to solve a real life equation is I always read the problem first. And sometimes I have to read it 2 or 3 times to really understand what it's saying to me. So let's do that. Craig went to the video game store with $100. He bought a video game system for $65, and then he bought games for $5 each. What is the greatest number of games that Craig could have bought? So when I read this, I know 3 things. I know that he has a total of $100. So I'm going to highlight that he has $100. That's my total. That's going to be on the other side of my equal sign. I also know that he bought a $65 game. So in math terms, that is a constant. It is not going to change. I know he spent at least $65 on a video game system. And then it says he bought games for $5 each. Now, this tells me what I don't know. I don't know how many games he bought. So I'm going to highlight that. G is the variable that I'm going to use. And I know that they were $5 each. So however many games he bought, they were $5 each. So now I can come over here and write my equation. Undo. Let me come over here. Okay, so this is what I know. I know he spent $65. I know that he also is going to buy games, but I don't know how many. But I do know that he spent $5 on each game, whatever he bought, $5 each time. Then I have an equal sign, and he has $100, so he can't spend more than $100. So my equation is 65 plus 5g equals 100. Of course, it doesn't matter if it says 5g plus 65. That's the same thing. It doesn't matter how the order you put it in. So I can now solve this. So I'm going to go to my paper. Let me write it down first. 65 plus 5g equals 100. And I know I'm dealing with dollars. So let me go here. So on my paper, I would have 65 plus 5g equals 100. Again, just like with all of our others, we're trying to get our variable by itself. So we're going to subtract 65 from both sides. This one goes away. We're left with 5g on this side. 100 minus 65 is 35. And then I know I need to divide both sides by 5. So G equals 7. So I'm going to go back. G equals 7. I know that G stands for games. And my question says, what is the greatest number of games that Craig could have bought? I just figured that out. He could have only bought 7 games. Let me put in a text box. So G is equal to 7. He could only buy 7 games. So let's try the next one. This one says Jordan bought 4 shirts that each cost the same amount. and one pair of jeans that cost $40. The items he bought cost a total of $180 before tax. What was the cost of each shirt? So this is what I know. I know the total was $180. The total was $180. I know he bought one pair of jeans and they were $40, so that's a constant. It's not going to change. This is what I don't know. I know he bought 4 shirts, but I don't know the cost. So he bought 4 shirts, and the mystery here is the cost, so I'm going to use a variable of C. So let's write that equation. So we know there was 4 shirts. We don't know the cost, so that would be 4C. He bought 4 shirts. We don't know the cost. We know he bought one pair of jeans, so that would be plus, and they were $40. And we know his total was $180. So now we can go to our paper and figure that out. So we have 4C plus 40 is equal to 180. So let's go to our paper. Okay, 4C plus 40 equals 180, and this looks very familiar. So we're going to subtract 40 from both sides. And we are left on this side with only 4C. So we divide both sides by 4. We're left with only C on this side. And 140 divided by 4 leaves me with 35. So what were we wondering? We were wondering, what was our question? It was, how much was the cost of each shirt? C is equal to $35. Or I used S, sorry. Let me change that. I had put S yesterday. $35 is how much each shirt was. Okay. Remember, it doesn't matter what your variable is. I used a different one than I would have used when I made these slides, so it doesn't matter what the variable letter is. It just matters what the answer is. Okay, let's do the next one. This one says Xavier buys 4 snacks and 2 cans of soda. Each snack cost $1.25, and each can of soda cost S dollars. Xavier's total for the snacks and soda was $8. How much did each can of soda cost? So here we don't know how much the soda was. So that is our variable. Let's see what we do know first. We do know how much he spent. He spent $8 total, so that is our total. It goes on the other side of the equal sign. We know that he bought 4 snacks, and they were $1.25 each. What we don't know is we know that he bought 2 cans of soda, but we don't know how much each soda cost. But it tells us that we are going to cost S dollars. So we're going to use S for our variable. So how could we write this? We could write this several different ways. So we know it was $8. We know he has 4 snacks and they were $1.25 each. So I could write it like this: 4 times 125. We know he bought 2 cans of soda, but we don't know how much they were. So we're going to do plus 2S. because we know he bought 2 cans. We just don't know how much they were. And we know his total was $8. So I'm going to write that on my paper over here, and then we'll go to our paper. So 4 times $1.25 plus 2 cans of soda equals $8. Okay, so we would distribute this just like any other time. 4 times $1.25. So I would go here, 1.25 times 4 is equal to $5 plus 2 cans of soda equals $8. So then I would subtract 5 from both sides. I would be left with 2s is equal to 3. Then I would need to divide both sides by 2. And s is equal to $1.50. So each can of soda was $1.50. I know that because 3 divided by 2, I just knew that. I'm sorry, I should have worked that out. So if I wanted it to be a decimal, since it's money, I would just put my decimal in. I'm left with 1. I bring my 0 down, and I know that 1.5 in money would be $1.50. So let's make sure that's what it's asking us. How much did each can of soda cost? That is what it's asking us. So let's put in $1.50. This one says Mr. Perez ordered 12 new jerseys for the middle school baseball team. Each jersey cost the same amount. He paid $10 for shipping, and the total cost of the order was $190. How much was the price for each jersey? So let's highlight what we do know. And like I said, sometimes I have to read these 2 or 3 times to understand it. It's okay for you to reread to try to comprehend what it's asking. You may not always pick up the first time exactly what it's asking. So just make sure you read it and think about, what is it saying to me? So this is what we know. We know the total. The total cost was $190. So we know what's on the other side of our equal sign. We know a constant. We know he paid $10 for shipping. This is what we don't know. We know he ordered 12 jerseys, but we don't know how much each jersey cost. So that is our variable. The J is our variable. So let's write this equation. So he ordered 12 jerseys. We don't know how much the cost is, so J is the cost. He paid $10, and his total was $190. Uh-oh, what happened? Let me go back. I must have hit the wrong button. I did, because it's got an eraser now. Let me fix it. His total was $190. Okay, so let's go to the paper. 12J plus 10 equals 190. So 12J plus 10 equals 190, so we're going to subtract 10 from both sides. That would leave us with 180. Now we divide both sides by 12. and J is equal to 180 divided by 12 is 15. So how much was the cost of each jersey? $15. $15. Okay, let's do the next one. A phone company charges a monthly rate of $60.10 per text sent. Tara sends 100 text messages this month. How much is her phone bill B going to cost? So, what do we know? We know that each month she's charged $60 just for the phone. We know that it is 10 cents per text sent, and she sends 100 text messages. What we don't know is what is the total. What is her bill going to be? We don't know the total. So, let's write this out. Our equation here would be B is equal to $60 plus 0.10 times 100. So whatever we get on this side, once we add them together, is going to be our total. So let me write that down so I can show you how that works. B equals $60 plus 10 cents times 100 text messages. Okay, so the first thing I would do here is distribute this 10 cents. 100 times 10 cents. I would do this. 1, 2, 1, 2. So that is $10. So $60 plus $10 is equal to B. So her bill is going to be $70. So she's going to pay $70 this month for her phone. That's pretty cheap compared to what I pay every month. Okay, we got one more. A local pizzeria charges $2.75 for a plain slice of pizza and adds 50 cents for each additional topping that you want on it. Write an equation to find the total cost C that can be used to represent this situation. Okay, so this is what we know. We know that it's $2.75 a slice. We know that it's 50 cents per each additional topping. What we don't know is how much the total cost will be. Okay? We also don't know how many toppings they're going to have. We haven't really done this where you have two variables. We don't know how many toppings there's going to be either. So let's do a T for topping. Let's write our equation. So a base slice is $2.75 plus 50 cents per topping is equal to your total cost. So We're going to have two variables in this one. Don't worry, we won't be going over this anymore. I just wanted to point out. We also don't know how many slices they're going to buy. So let's do that also and ask for a slice. Yes, I'm telling you, it gets harder, and this is solvable, but we're not in 7th grade. So we know that they're going to buy slices, but we don't know how many. So really, we could put 275 S plus 50 cents T is equal to your total cost. So for instance, if I took Carson there and I said, okay, he wants 4 slices and he wants pepperoni on each slice, then I would know that I needed to pay $2.75 times 4 plus 50 cents times 4 because I would be adding pepperoni to each slice, and that would equal my cost. Don't worry about that one, but I did want you to see how you would work that out in real life. And like I said, you do a whole lot of algebra in real life. You just don't think of it in terms of variables. You just think, okay, well, my kid wants 2 pairs of shoes and they're this much, and then I got to pay this much tax, or it's buy one get one free, so I need to get this one a pair of shoes, and then this one will get another pair of shoes for free. I mean, you do algebra every day in real life. You just don't think about it as algebra. So I hope this was helpful to help you decipher what information you need, what information you need to know to get your answer, and you have an activity to do to turn in today. I hope y'all have a great weekend, and I'll see y'all next week. Bye bye.